All right, this first part's going to be really short. I just want to get started on a little bit because the lesson, it's not super long, but it'll make it so I don't have to teach so much tomorrow anyway. Okay, so let me go through a couple things. I think I'm going to actually jump to example 2 because we don't have a whole lot of time. But we are eventually, so it says solve by taking roots. So we're talking about square roots, that kind of thing. Like right now we're only doing square roots. Eventually we'll do cube roots, fourth roots, and things like that, okay? But right now we're just doing square roots. So here's an example. I'll just start off. And this is something, again, I know I sound like a broken record saying this. You guys don't even know what a broken record is, do you? Yeah, okay. It skips. You ever do an old record and sometimes you get scratches on it and it skips. Anyway, so, but this is something, this right here is an Algebra 1 topic. But if you didn't learn it in Algebra 1, we're going to do it in here. So let's do this. Let's before we actually do the example, let me just show you something super quick. So in algebra, says that we can do this. If I had the square root of 15, all right, we have a little rule in algebra. I think I taught this to you last year in geometry, to tell you the truth, that we have a little rule where I could go the square root of 5, because what times what? Let's do it like this. What times what is 15? 5 times what? 3. And we have a rule. I think there's a name for it. I don't remember exactly what it is, but this is what it does. It's very simple. It's very important, though. Okay, it's a simple rule. It's pretty basic. It's almost intuitive, but it's a very important rule. When I have two things being multiplied under one big square root, we have a rule that says I can break it down into their own little individual square roots, like this. Everybody see that? Yeah. Put a times in the middle. All right, so it's a real basic kind of thing. So, for instance, if I had a number like the square root of 20, and they said to simplify it, I'm starting off really easy because I think they make some assumptions that you already know how to do some of this stuff, and so they give you a fairly big number and ask you to simplify it. I'm just going to start off with a really simple number. So there's several things that multiply to be 20. Would you agree? Yeah. There's 1 times 20, there's 2 times 10, there's 4 times 5. Agreed? So if I wanted to simplify this, and this was in a square root, I could use any of those numbers and continue to break them down. I could break them down into their prime numbers, and maybe another day we'll do that. But for right now, since we're kind of short for time, I want to break this down into two numbers so that if I took the square root of one of those numbers, it's going to come out to a whole number or an integer number. It would be a whole number. All right. So like, what am I going to use? 1 times 20? No. 2 times 10? Can I take the square root of 10 and come out to a nice whole number? No. Can I take the square root of 2 and come out? No. So what's my other choice? Do you see a number in there that you can take the square root of? Yeah, square root of 4. So that's how I like to do this, okay? When they ask you to simplify, sometimes they say simplify the radicals. That little check mark looking thing is a square root, but they also call it a radical. When I simplify radicals, I like to think of something that if I take the square root of, it'll come out to a nice whole number, all right? So let's do this. What I'm going to do now is apply this little rule that we just talked about. So how could I rewrite this? The square root of what? The square root of 4 times the square root of 5. Now, can I simplify the square root of 4? Yeah, square root of 4 is 2. And can I do anything with the square root of 5? Can I break it down any further than that? No, it's a prime number. I can't do that, so I just leave it square root of 5. So the square root of 20 is exactly the same thing as 2 times the square root of 5. I'm not going to do it now, but you can put it into a calculator if you wanted to, and you could check. All right, and it would come out to the same exact decimal, all the way to the very last decimal place on your calculator, okay? Everybody with me on that? You did that in Algebra 1, didn't you? Sure you did. All right, so what they're going to ask you, this is the actual example now, I'll lead you up to it. What if they ask you to simplify that? Yeah, that's what I would do. Now, there is a way that you could simplify it. You could break it down into their prime factors. There's a time when that's a good thing. And again, I keep saying this, but for the sake of time, I'm not going to do it. But what do you think? Let's just do it right here. Square root of 450. Let's break this down into the easiest numbers that I can. So, like, what times what is 450? 45 times 10 is a perfect one to do. So 45 times 10. Let's keep breaking it down a little further. Why do they keep dribbling a basketball? Well, they're not being dismissed. They're just hanging around the hallway. All right. Anyway, I'm just complaining to myself. I'm not really looking for answers. So, yeah, you could have done that. That's true. You could have done that. All right, that would have worked. But this will work too, because these are numbers that just kind of pop in your head pretty easy. It ends in a 0, so 45 times 10. Let's break down 45. What times what's 45? Yeah, 9 times 5. So let's go 9 times 5. Okay. What about 10? 2 times 5, right? Or what? 5 times 2? I'm writing that for a reason. I don't know. You might see it. So now, look what we got. Now I can start breaking stuff down, because I know 9. I can take the square root of 9, correct? Watch this. What's 5 times 5? It's 25, isn't it? And then, what? Square root of 2. All right? You guys see that? Again, I'm looking for numbers that I can take the square root of. All right? So the square root of 9 is 3 times, what's the square root of 25? 5. And then what can I do with that? Just leave it square root of 2. What do I do with this? 15 square root of 2. Now, 225, but Mia, you said 225, and that is true, because 225 times 2 is 450, correct? And the square root of 225 is 15. But that's not a number that a lot of people just know off the top of their head. Would you agree with that? These are numbers that you could do that you know off the top of your head. All right? All right, so yeah, you could have gone directly to this, and that would have been fine. If you use your calculator, right, you could do that too. But I'm just trying to do this the way I would do it if I didn't have a calculator, if I'm just, thinking, and like square root of 225, I actually knew that, but a lot of students don't know that. So, but every one of you knew 450 was 45 times 10, right? And so on. Does that make sense? Yes. You don't have to do that. You could have done this. Like anytime I have this, like if I had the square root of 7 times 7, what's that equal to without doing any math and making it a 25 or whatever? This would be the square root of 49, which is what? 7. So what's the square root of anything times itself? It's just itself, right? Exactly. I could do weird numbers. I could do like square root of 132 times 132, couldn't I? And what's that? It's just 132. I just did, and you could have done that here, all right? You could have looked at it and said, oh, square root of 5 times 5, that's just a 5. But since we're kind of new at this, I thought I would just multiply it together, because I see the square root of 25, and I'm, oh yeah, square root of 25. I know that. That's 5. Does that make sense why I did that? Okay, you didn't have to do that. I just did it to make it a little easier for you. All right, we'll do some more of that stuff tomorrow. No.